at a very rapid level. Mobile applications, desktop applications, web applications, and even businesses, every business of any domain, they're trying to switch to, utilizing some software applications for their transactions. Even grocery stores nowadays, they have their own e-commerce sites. To that extent, software has evolved and grown. So to meet the demand of, developing an application and delivering it to the client, even this approach should be faster rather than, delivering a product to the client after 2 years or maybe 3 years and so on. So according to the pace, what happened now, we started relying on microservices applications. The application development in the current scenario is happening at a microservices level, right? Instead of focusing on one entire application, we're breaking the application into multiple modules and delivering it to the client. Why is that? Means a traditional way of software development got a lot of challenges, like if at all client wants some changes in his requirements, we don't accept them in traditional SDLC. Client is not an active participant. Client doesn't know what's happening with the software right at the beginning. Accuracy of estimations of the client might go wrong. Schedules keep extended and that impact the cost overruns. And ultimately, once an entire application is developed, then the project is moved to testing phase. So there is no much time left for testing team to test the issues and fix the defects and so on. So traditional way of development, software development became quite cumbersome, and now software organizations started implementing a different way of application development, which is a agile way of software development. What is agile way of software development? Over here, we develop microservices applications and deliver it to the client in the format of increments. We don't develop an entire product at a time and release it to the client. Instead, we break the application into multiple chunks and deliver the product to the client in the format of increments. With this approach, all the major drawbacks in traditional way of software development, they're getting to an end. Since the development path, it's not a one-time activity. Development keeps on happening for every iteration, for every increment. It's a continuous activity that happens from, throughout the software development lifecycle in Agile. Right? So if client wants to change his requirements, yes, it is accepted in Agile. And client is an active participant too, because client is able to interact with the software because we are not releasing the product, an entire product to the client, but a product in the format of increments, we are delivering it to the client. Excuse me, friends, am I audible? Facing any challenge? My voice is clear?
Yeah, it's clear.
Okay, fine. Yeah, so all the challenges which are faced at traditional level, now we are getting a solution when we implement agile way of software development. So these are all the terms and these are all the trends we implement in agile. Like we develop a product to the client in incremental fashion and deliver it to the client within a very short time frame. Of course, I'm not saying the entire product, but a product with at least some, some features we develop and deliver to the client. With this approach, client now got the opportunity to interact with his application software within a very short time frame. Now, let's say if we take the example of a banking firm is expecting a software from us. If we got to develop the entire application, let's say we collected all the requirements from the bank and they gave us around 50 features, an application to be developed with 50 features. If we develop all the entire application with all those features and deliver it to the client, let's say if it takes 2 years of time, client cannot commence his business until his software is ready. But in Agile, what we try to do, we break that entire software into multiple pieces, prioritizing the requirements of the client, address them right at the beginning in the earlier increments, and deliver a product to the client in incremental fashion. Meaning, out of those 50 features, maybe we develop an application with only 5 features initially, develop the application, write code, test the application, review it several times, and finally release it to the client. So for every iteration, for every increment, we assign a time duration, which is called as a sprint. And the industry standard sprint time duration varies from 2 weeks to 4 weeks. So by the end of 2 weeks or by the end of 4 weeks, according to your sprint duration, what should you do? You got to achieve the motive, which is make sure a software release for that increment happens in time, ensuring quality. So an agile team ensures to fulfill, the motive and try to make sure they release the product to the client in time. Yeah, friends, and in this process, requirements can be collected and changed, throughout the development life cycle. Tests are happening at every increment level rather than, tests are happening one time in monolith application type. Reduced risk and earlier software release. How can we assume? How can we ensure that client gets to know what's happening with the software within a very short time frame? If at all some increment went wrong, it's easy for us to identify the challenge and not continue that in the next iteration and so on. So these are some of the advantages or some of the some of the best features with the agile way of software development. Over here, just for us to understand real quick, let's say, friends, the image towards the left with multiple boxes, just think of it as a whole product we got to deliver to the client. But what we do in agile, we don't develop and deliver the entire product to the client at a time. Instead, we break the application into multiple modules, and module by module, we deliver it to the client. So for doing that, we plan things accordingly, write code, test the application, review it several times, and by the end of a sprint duration, release the product to the client. So the main motive of agile is to make sure software releases happen in time, ensuring quality. So agile is focusing mostly on the first two business needs. Right at the beginning, we discussed 4 business needs: continuous delivery of a product, ensuring quality, make sure we identify some cost-effective solution, and ultimately make sure that the product released to the client is always running. Right? No outages at the client level. So agile way of software development, ensuring that the first two business needs are met. However, even in agile way of software development, there are some challenges. Like, as you know, software development to delivery, it's not a one person or one user activity. There are a lot of developers, there are a lot of test teams and multiple personnel involved. Right? Build engineers, release managers, system administrators, storage administrators, project managers, front and back end developers, and so on. If at all these teams strive to work towards the motive, make sure releases happen in time, ensuring quality, things happen as expected. But what if these teams are pertained only to their roles? Now, let's say a developer, his role is to develop an application, and once an application is developed, he just keeps quiet. He doesn't contribute anything at all to the project. Likewise, the test team, QA person, he does some tests and he does only his job and won't consider anything at all. So with this broken approach, what's happening is even agile way of software development is not getting fulfilled, meaning we are not delivering a product to the client in time. So business needs are not getting met because of no proper coordination between teams in agile. And let's understand this with some use case or some workflow of agile way of software development. Let's say, friends, a team of developers, they're working on some increment, one increment, and multiple developers, they're writing source code for some increment, and they're maintaining their source code, integrating their source code into some version controlling system. Let's say some Java code they've written, and they maintained all their source code in some version controlling system. And now there's a team, build a team. Their responsibility is to download that source code, pull that code, perform some builds on that source code written by developers, create an artifact and a package. Once an application is created, that application should be deployed to QA so that a QA team performs some tests on the application. If challenge is identified with the application, QA routes back to the development team, asking them to rework on their source code. And developers again rework, fixing the challenges and maintain their source code at GitHub level. And again, build team, they got to pull that new change, create an artifact according to the new change, deploy it to QA, and again QA got to rework on that application. And there is a team called system engineers. Their responsibility is to prepare the QA environment with the necessary packages and libraries for this artifact to run. If all these teams, I did simplify this entire workflow at a very minimal level. However, there are a lot of other steps involved too. Yeah, friends, but let's just say if these teams are working in proper coordination, things do work fine. But if at all these teams are not working in sync, what happens? Delivering a product to the client might get delayed. If at all a product is not delivered to the client in time, what happens? That impacts the credibility of the software organization. Yeah, friends, now we are living in a world of reviews. If I order something online, Amazon, and the product is supposed to be delivered to me by 31st of December, Jan, and it didn't get delivered even today. Let's say maybe tomorrow the product is going to get delivered to me. I'm expecting the product to be delivered by 31st Jan, and it's going to get delivered tomorrow. Now, what happens? A furious me, I become a writer of the decade and I start leaving a bad review, right? Likewise, here, software organizations with they are doing business in in millions of dollars, and if they are not delivering a product to the client in time, just imagine what the impact is going to get added on the software organization from the client. So we have to ensure that at any cost we achieve the motive releases ensuring quality. So if teams are not in proper coordination, that may impact a software release, which obviously affects the credibility of software organization. So this is one major challenge identified in Agile. And the second challenge is an application is developed by some developer. That application is working absolutely fine on his machine. On a developer's machine, the application which he developed is working absolutely fine. But the same application, when deployed to QA, the behavior of the application is entirely altered. What might be the challenge here? Means, let's say the application developed by some developer is expecting some set of packages, some particular versions of packages and libraries. But the same application, when deployed at QA level, let's say the environment of QA is configured with a different set of packages and libraries, and obviously altering the behavior of this software application at QA level. Now, QA routes back to developers saying the application is not working fine. And developers do say the application is working absolutely fine on our machines. And this leads to a cat fight between developers and QA, saying QA says the application is not working fine, and developer says it's working fine. It works on my machine. This quick acronym to IWMM. It works on my machine. And QA says it's not working on my machine. So even this approach is not letting our application deliver to the client in time. And by the way, what might be the problem here? Why the application's behavior might change from platform to platform means if we are not delivering a proper content at the application level, or sorry, at the environment level, that might lead the applications behave as abnormal. So friends, to address these challenges, what we do, what are the solutions we're going to implement? How do we make our agile process of software development better? Means we adapt DevOps principles and strategies. We adapt DevOps culture and try to make sure that releases happen in time, ensuring quality. And remember, DevOps activities are quite complementary to agile way of software development. So right at the beginning, I did say there are different disciplinary activities for developing an application software. You can adapt a waterfall model or spiral model, incremental model, V model, RAD, and so on. But if we are trying to become a DevOps engineer, our focus should be more and more on agile way of software development. How software development happens with agile, how the sprints are broken down, what comprises of a scrum team in agile, what are the responsibilities of a scrum master, what are the responsibilities of a developer, a QA person, everything we got to have a very high level of understanding. Anyways, that we'll discuss in our course. For now, the problem statement we understood, agile, the better way of software development, we are making sure we release the product to the client in time, ensuring quality. But these challenges, however, are not letting us do the job. So now what we do, we try to make sure we adapt DevOps activities, bringing forth communication, collaboration, and automation in the entire, software development process. Make sure that there is a proper conjunction, connectivity between development teams as well as operational teams. Since if coordination is lacking between development teams and operational teams, what happens? Product getting delivered to the client is getting delayed. Likewise, reduce manual intervention and make sure you add a lot of automation. So for doing these activities, what we do, we bring forth in our in our project workflow, agile workflow, what we do, we bring forth the DevOps activities. We got a bunch of tools, a set of tools, using which what we do, we try to automate this entire process to the max, to a maximum level. All the activities, what we try to do, we try to automate them, rather than letting some developer, once he write code, a developer should update a build engineer to create an artifact. A build engineer should request, let's say, a system administrator or system engineer to configure QA server with some necessary packages and libraries. So instead of manual approach, what we do here, once a developer writes some source code and maintains his code at GitHub level or some repository level, we configure a CI server here, a continuous integration server, that does all the activities for us, like getting the source code, perform a build, create an artifact, deploy the artifact to QA, and if at all the organizations are adapting TDD approach, test-driven development approach. We even automate the process of testing, running some automated test cases written by QA in advance. A QA team writes some automated test cases in advance in TDD approach. And those test cases we run on the artifact deployed at QA level. If challenge is identified, we configure a CI server with some notification channels so that a CI server sends immediate notifications to the entire team whenever it fails, whenever the project fails at any level over here. So if at all challenge is identified, a CI server, we configure it with some email notifications or some Slack notification channel so that the entire team gets notified. Downloading the code, there's a problem, a CI server notifies. A CI server, we integrate it with multiple tools like SonarQube, Nexus, likewise, Tomcat, and Maven. With some of these tools, what we do, we integrate our CI server, Jenkins, and perform all these activities, all these end-to-end activities. We try to automate them. And the problem we faced earlier, if at all the application is it's expecting some dedicated packages, and if those dedicated packages are not delivered, what's happening here? The application, we are facing challenge like IWOMM problem. Now, to address this challenge, what we do, we adapt a container technology here, meaning a containerized application. It behaves the same across all the platforms. So now we perform a build and create an artifact, a software package with all the necessary libraries for the package to run, equipped or packed together as as an image, a Docker image. Now, a container application, the advantage with a container application is it carries its necessary packages and libraries along with the application. So now, whatever the application is developed by a developer, the same is reflected at QA. Whatever the application is approved by QA, the same is released to production environment. Meaning, at all levels, the application behaves the same. No matter whether you're using a Windows platform or Mac OS or CentOS, the application's behavior is the same across all the platforms. We try to bring that sort of uniformity. Say, friends, some best examples are WhatsApp application in our mobile phones. Though our mobile configurations aren't the same, some of you might be using Apple phones, some of you might be using advanced Android phones. Our hardware configurations are different, our software configurations are vivid. But still, across the globe, all smartphone users are able to consume WhatsApp application, right? And how is that happening? We are bringing forth that sort of uniformity at the application level. So do the software development here too. We make sure that the application developed by a developer should reflect the same across all the platforms. So for doing that, we got a container technology, and we rely on creating Docker images and create containers out of them. And the containers behave the same across all the platforms. So no more IWOMM problem. And we are automating the concepts to the max here. With some CI server, we are automating all these activities. And friends, to keep things simple, I did let this workflow very simple. However, there are a lot of other steps involved, like code quality check, UAT, pre-production stage, and so on. Just to keep things simple, I did simplify this workflow. This is how developers, when they write code, they don't need to update build team. Now we as DevOps engineers, we configure a CI server and set a pipeline job here so that whenever a developer uploads the code to some version controlling system, a pipeline begins and does all the activities step by step. Pull the source code, create an artifact, a container application, deploy the container application to QA, fetches some of the use cases, test cases written by QA available at GitHub, run those test cases at this, at this QA server level. Challenges identified, send notifications to the development team, ask them to rework on the source code. Everything is fine. Make sure the application gets released to production environment. So this way, we automate a channel of or a pipeline of activities here in DevOps. So trying to minimize the manual intervention and trying to automate things to the max. So what is automation, by the way? Say, friends, I got a car with some problem. My car got all sort of problems. Let's say problem with the windshield, problem with the tires, problem with the engine, problem with let's say the seating, everything. In all possible ways, I got problems in my car. Now, what if I take an approach like take the car to garage A, get the engine fixed. Next, take the car to garage B, get the windshield fixed. Next to the garage C and get the tires fixed. What happens? I'm complicating my actions of fixing my car. I'm just complicating things. What if I take my car to a one-stop solution, meaning to one single stop, get everything fixed in one single garage? Obviously, I'm saving time and I'm reducing my effort of taking it to the next garage and so on. Right? So automation, getting multiple things done in one go rather than doing things one after another manually. Right, so we got CI servers that do play a key role here in automating the entire process of software development to software delivery. And friends, now, yeah, somehow with the DevOps, we are able to fulfill the motive of Agile to make sure releases happen in time, ensuring quality. But how do you identify cost-effective solutions? Now, say client invested $1 million for his software product. And if you identify a solution, developing a product to the client, you invested all $1 million to get the solution. What is the point of you doing, what is the point of, giving that sort of solution when you're not getting benefited out of it, out of the amount invested by client? So what should we do? We have to identify feasible solutions that are cost effective in nature. So how we do that? Creating servers in the cloud, okay, rather than maintaining servers on premise. What if we hire servers from the cloud environment? What if we hire services from the cloud vendors like AWS or Azure or GCP and rely on the services till we complete our project? Once our project is done, we don't need those anymore and we unenroll from that cloud services. What happens? You don't need to invest much here when you adapt to the cloud. If we maintain everything on premise, again, if we relate this to a simple example, I want to travel from Hyderabad to Bengaluru, and if I go on my own car, I have to take all sort of, I have to consider everything like the car condition, fuel, likewise the toll gates. If I got to drive, I have to put all my effort driving the car from source to the destination. Everything I have to take care of. But what if I want to go and I want to make my journey hassle-free? I took a public transport like a train or a bus or some flight. What's happening? I just invest some money and that's it. My job's getting done. And And whatever the approach I follow, meaning a public transport, that is way too cheaper than me putting every sort of effort and maintaining or doing a journey on my own, right? Likewise, let's say if at all the servers setup are all on premise, you got to make sure that there is a 24/7 power supply to the servers. Likewise, you got to make sure that you add some uninterruptible power supply just in case if there is no power supply. Likewise, cooling facility you got to add. You got to dedicate some physical storage to configure your servers, a system administrator to monitor your servers, likewise a network administrator to identify the traffic, the amount of traffic getting onto your servers. Everything you are complicating here when you're going with what's say on-premise servers. Now, cloud became more and more popular, and organizations are moving from on-premise environment to cloud environment because they identified cloud is way much cheaper than relying on the on-premise servers. So we adapt all the DevOps activities, configure CI servers, QA servers, everything at the cloud level. Once our project is done, we may design role from that cloud platform, and cloud operates in such a way that whatever services we utilize, we pay only for those services. No need of taking care about your server health because it's taken care by your vendor. Cooling facility, 24/7 power supply, nothing at all. Administration, nothing at our end. A vendor should promise to deliver us a product which is always running, a server which is always running. If at all there's a problem, a vendor should fix that problem and give us a better solution. So organizations try to adapt what's a cloud environment, and now you find cloud native applications, containerized applications are booming. Yep, microservices applications, container applications getting deployed more and more in the cloud platform rather than the applications being maintained on premise. So with the DevOps, what we are trying to do, we are bringing forth solutions like making sure the applications are getting released to the client in time, ensuring quality, adapting cloud technologies here and automation here. We are reducing manual intervention and we are reducing the cost of the application development, making sure we are identifying feasible, cost-effective solutions. And one thing we are still lacking is making sure that the application at the client level should always be running, right? Reduced outages, the last business need of a software organization. Now, containerized applications, when you deploy in cloud environment, we cannot guarantee that the container application will always run. We cannot guarantee that. A container application might fail, or maybe a server in the cloud might fail. If that happens and the client's application is not running, what happens, friends? Let's say our client is of some e-commerce background, like a site similar to Amazon or Flipkart. The client got a lot of competitors too. And now the client's application is not working. Just imagine what if Flipkart is down for this entire day. We find a huge spike in sales on the site Amazon. Or example, UPI applications. What if a PhonePe is down for this entire day? We don't wait until that PhonePe application gets up and running. Till that time, we don't hold our transactions, right? We try to go with an alternate channel, maybe GPay or Paytm. So now one application's downtime is turning as a boon to another application. So organizations are pretty much aware of this. Clients are pretty much aware of this, and they want their application to be running all the time, 24/7. So how do we ensure that? How do we make sure that we understood container applications are best, and we are delivering applications in the format of increments like microservices applications to the client? But we got to ensure that the applications are always running. And how do we do that? Means how do we make sure of that? Means we got a tool, container orchestration tools like Kubernetes, OpenShift, Docker Swarm, Apache Mesos. These are some of the tools using which what we do, we identify the problem statement, why a container application might fail. The reasons are, let's say, a container application might be running out of some CPU or RAM. And then we got to add some more resources to the container and let the container up and running. Or maybe some process is running in the container, making it busy and letting it fail. identify the solution and let the container up and running. Or maybe the server where the containers are hosted, that server got crashed. And the applications, since the server is down, how can we access the applications in that server? Again, downtime. Or maybe the application developed is designed for only for 100 users access. But now the users accessing the application of the client are around some 1,000. Meaning the application is designated only for some set of users, but now multiple users, which we didn't expect, are trying to access the application at the same time. So even in that cases, service level agreements of that application do fail, and our application might not be available all the time. And maybe client wants to update his application from version 1 to version 2. During that transition, some customers of the client are accessing the application and the application is not available. So again, customers of the client are relying on the client's competitors. So there are a lot of other challenges too. We got to identify all these challenges and bring solution to make sure that there are no outages at the client level. So for doing that, we got a tool, Kubernetes, using which what we do, we make sure that we add self-healing capabilities to our containerized application. If at all a container fails, it should start immediately within no time. If at all a server gets crashed, we make sure that we maintain the application not on one single server, but in a distributed environment, so that on another server, the application gets created and it's available to the client. Right? Likewise, if client wants his application to be updated from version 1 to version 2, without end users facing any downtime, the application should get transitioned from version 1 to version 2. So for that, we got a concept called rolling updates. Likewise, if client's application is being accessed by multiple users, there's a huge threshold. The application should get automatically scaled up to meet that threshold. When there is no demand, again, the application should scale down to meet the threshold, to meet the minimal amount of users requirement. So this way, what we do with a tool called container orchestration tool, Kubernetes or Docker Swarm or Apache Mesos or OpenShift, what we try to do, we try to make sure that the applications are always running at the client level. The applications do not face any downtime at all. Yeah, friends. So the fourth business requirement, making sure that the application at the client level should always be running. We are trying to fulfill it with a container orchestration tool, Kubernetes. Likewise, once the project is commenced, now to understand how far we came in a project, let's say module 1, how far it came. A sprint duration is getting closer, whether the application is going to get released in time or not. To monitor things and to make sure how things are happening in an entire DevOps workflow, what happens, we got a tool, Jira, a issue tracking tool, using which what we do, we make sure that the assigned task to some user is completed in time and things are happening as expected. If not, what are the measures to be taken? So a project management tool, Jira, what Scrum Masters do, they monitor things, whether all the activities are happening in time as expected or not. Yeah, friends. And finally, the ultimate stage in DevOps is monitoring the applications and servers. When you automate things, automation will take care of doing all the activities, CI/CD activities. But we got to ensure that the applications are working absolutely fine. No outages at the server level. Servers might not be running out of storage or RAM or CPU. We got to identify, analyze whether the whether the applications running in the servers are working fine or not. The servers are equipped with enough resources or not. We got to continuously monitor the servers and applications. Again, it's similar to, say, friends, Tesla cars back in the past. There were use cases where people used to sleep at the wheel, setting up some threshold or setting up some cruising control. The car should cruise at 60 miles per hour. And we saw use cases like, drivers used to sleep in the cars itself. But that is a dangerous thing, right? If at all automation fails, that's pretty danger to the to the commuters as well as to the pedestrians and so on, to others too who are going on the journey. So to avoid that, now what did they do? They added some constraints like every 10 seconds, the car should identify whether that respective driver is blinking his eye or not. If not, the car gets to gets to a halt. Likewise, now when we set up automation, we don't rely on completely automation. We have to make sure whether automation is happening fine or not. We got to ensure whether a Jenkins server is working fine or not. Whether, let's say, QA environment, the servers are working fine or not. The applications are working fine or not. So for doing that, what we do, we enable monitoring on the applications as well as the servers. We got a tool, Prometheus, using which what we do, we make sure that the applications and servers are running fine. If not, we take preventive measures rather than letting the entire cluster down and take reactive measures. What we do, we take preventive measures. If at all some server is running out of storage, we may deploy some storage onto the server and keep automation alive. Yeah, friends. So the last stage in DevOps, continuous monitoring. Monitor the applications and servers and make sure we take preventive measures as and when required. Yep. And these are the tools we are going to cover in our DevOps journey. The basic prerequisites to get started off with DevOps, we should have very good understanding on Linux concepts, shell scripting concepts, followed by that some networking basics. If we know these, then we are good to dive into other tools like Git and GitHub, a version controlling tool, where at times you as a DevOps engineer, you integrate your infrastructure automation tools with the source code written by developers. So an infrastructure is also gets created in the fly with the infrastructure automation tools like Terraform. SonarQube as a tool to understand whether the code written by developers is according to the coding standards or not. Nexus as a tool for preserving the artifacts. Tomcat for deploying Java-based applications into QA environment to production environment. Jenkins as a tool for entire CI/CD automation, continuous integration and continuous delivery. Once a developer write code and upload the code to version controlling system, from there, all the activities of CI and CD, continuous integration and continuous delivery, are handled by Jenkins. We enable automation at Jenkins level and make sure all the activities are done. All the pipeline of activities are done step by step. Docker as a tool for containerizing the applications. Rather than creating monolith applications, what we do, we're relying on microservices applications, making sure that our application is broken down into multiple chunks or multiple modules. With microservices, what happens, friends? Let's say if an application is down, it's pretty easy for us to debug what is the problem with the application. Turning to that respected microservices container, fix that issue and get the application again back and running. If at all it's a monolith application, it failed. It's very difficult for you to understand the problem, understand the root cause, analyze it, fix it, and get again the entire monolith application back and running, up and running, right? So we focus more on Docker, understand how to break our application into multiple containers and maintain a multi-container architectures at Docker level. Followed by that, we learn a tool, Ansible. Let's say the containerized application should be delivered to the client, where the client got hundreds of servers. Now, how do we ensure that the application is deployed at the client level to hundreds of the servers of the client? So for doing that, we got a tool called Ansible, using which what we do all the configurations of hundreds of servers from one point of control. Kubernetes as a tool, as discussed, make sure that at any cost, the containerized application should always be up and running. And Terraform as a tool for automating the infrastructure at AWS cloud level. Python as a scripting element for automating some of the activities like Docker Python automation, Ansible Python automation, Python Jenkins automation. So to bring forth automation to a next level, we explore some of Python concepts too. And Jira as a tool for project management. It's just a managerial concept, and we explore just what are stories, epics, bugs, codes. What are epics and stories? Bugs and code smells are of SonarQube. So we understand how the project is broken down into multiple stories, whether they are getting completed in time or not, tasks are getting completed in time or not, how much time it's taking for completing a story or a task, everything analyzed at Jira level. Argo CD as a tool for deploying Kubernetes applications through a UI, because majority of the activities we do at Kubernetes level through Kubernetes manifests, kubectl, and some command line interfaces only. So to understand things better and analyze things, what we do some of the deployments, automate the infrastructure with Argo CD as a tool. And finally, Prometheus and Grafana as tools for monitoring the entire infrastructure. Yeah, friends. So these are the tools we are going to cover in our DevOps journey. And since you admitted that you are from IT background, I tried to simplify things, not explaining all the concepts in detail here. So if we are from non-IT, I would have explained everything, like what happens in requirements gathering, collect all the requirements from the client, do prototyping, ask questions. What is the problem with the existing software and what should we do now in the new software? So requirements gathering at a high level, what happens in analysis phase and so on. I would have explained everything in detail, but we know already. So why to again discuss all those concepts? I just try to keep the session minimal. Yeah, friends. So this is what, DevOps in a nutshell. Every software organization got business needs and we got to fulfill them at any cost. For doing that, we got agile way of software development in the current day scenario. Organizations adapted agile way of software development. However, there are challenges at agile level, and we are inducing DevOps principles and practices to make sure that agile way of software development is taken to the next level and the organization business needs are met. Yeah, friends, that is all the crux of DevOps thing. Yeah. So now it's your time to raise questions, and I'm happy to address your queries. Yeah, friends. So any questions from our discussion? Yeah, go ahead. Someone unmuted.
Yes, Saukya, Prudvi, and Rahul, any questions?
I'm good for now.
Yeah, I'm good, brother.
Yeah.
Were you able to understand what Prashant is saying?
Yeah.
Yes.
Yeah.
Okay. Yeah, we'll get back to you, Prashant. Thank you for your time.
Well, Venkat, thank you
Prashant.
everyone for your time.
Thank you, Hemant. We'll get
Yeah.
back to you.
Thank you.
Thank you.
Thank you.
Good day. Yeah.
Hi.
Hi, anybody is here? Hello.
Yeah. Hi, Saukya.
Yeah. Hi, Prashant. So this is the end of the session, or is there
Yes,
anything?
okay. So I try to wrap up things faster for today, just
Oh,
because
okay.
you know all these concepts already, right?
Yeah.
So,
Yeah.
yeah.
Yeah. Yeah. I have an idea on the agile and the software development life cycle.
That is where again
Yeah.
discussing the same concepts and trying to bore you. It's not my intention. So
Yeah, no, not boring.
Yeah,
But yeah, I came to know like what the DevOps
I hope you
is.
gained some insights out of this discussion. What
Yeah.
exactly is DevOps?
Yeah. Yeah.
Fine, Saukya.
Actually,
Yeah. Please
yeah,
go ahead.
actually I have like I thought they will discuss about when the training would start. So
Yeah,
I was
you
waiting
can
on that.
reach out. You can reach out to the management, Saukya, either to Venkat or I'm not really sure of to Hemant.
Oh, okay. Okay, so I thought they will discuss that now. So I was still on the call.
Yeah, you can check with them so that you know.
Oh, okay.
We'll
So
get to
you
know.
are the one who will be
Yeah,
giving
I'll be the
training.
trainer for this entire course, end-to-end course. Yeah, true.
Okay, so what the concepts you have told now, so you will be covering those in the training.
Yes, initially we begin off with Linux and shell scripting, followed by that version controlling, Jenkins,
Okay.
Docker, everything in a sequential manner. And,
Okay. So meanwhile, do we need to brush up something? Is there anything like
Well,
that
if
you
you know
suggest
Linux,
something?
if you know Linux concepts already, well and good. If not, we can
Okay.
continue with our regular classes. I'll teach you everything from scratch, and then
Okay.
we are good to dive into actual concepts, DevOps concepts.
Oh, okay.
But agile, understanding agile way of software development is very important. So don't think that you got to understand what are Scrum meetings, what happens in the sprint retrospective, all those we should have good understanding.
Yeah, I have an idea on that. But still, yeah.
True, sir.
Okay. Yeah, sure. Okay, then thank you.
So please reach
I'll
out to
get
them.
back
They
to
will,
yeah,
reach
sure.
out to them. They'll update you about the next proceedings.
Yeah, sure.
Thank you, sir.
Thank you.
Yeah,
Thank you,
you.
Prashant. Yeah.
Thank you.
Yeah, thank you. Bye-bye.